So just looking forward to next week. We've got 2 talks coming up of the 3D LiDAR modelling and also of R2M. So have a look on the Frontline Industry School website for future up and coming events. But you want to start recording, and over to you, Stella.
Thank you. Good afternoon, everyone. I'm Stella Matthews. I'm Assistant Project Manager on the H21 project. And I'm going to talk to you about the programme of projects, because H21 is kind of, it's more than one project, and I'm going to talk to you about 2 specific projects today, but we have a whole broader programme of projects, but I'll talk to you about the 2 main ones that the award was about. So as I said, it's a programme of projects. It seeks to demonstrate that we can use the existing natural gas infrastructure to transport 100% hydrogen. I'm not sure if any of you are familiar with H21, but it started way back in 2015 with a project called H21 Leeds Citygate. And the report from that was released in 2016, and that report was a feasibility study, and it took the City of Leeds, due to it having a network representative of a UK network and a population sample representative of the size of the UK. And from that feasibility study, we proved that it was technically viable and economically possible to convert the natural gas grid network to 100% hydrogen. Following on from that, in November 2017, we were successfully awarded Network Innovation Competition funding from Ofgem, and we kicked off our H21 NIC project, which is what I will start by talking about today. It's important to note that the H21 NIC project that I am going to talk about, it is actually the first collaborative project that all the all the GB gas distribution networks have collaborated on. So that in itself is an achievement. So the H21 NIC project, we have actually split it now into phase 1 and phase 2. So we initially got funding for phase 1 in November 2017, as I just stated. Phase 1 was split into 2 stages. We have phase 1A and phase 1B. And what we're looking at is, for any showstoppers really, is the network as we see it today fit to transport 100% hydrogen? So phase 1A was in collaboration with our project partners, the HC Science Division at Derbyshire. And we actually had a purpose-built facility up at HSE's Buxton site. And there we tested leakage. So we compared leakage rates between natural gas and hydrogen. And we tested on the existing 0-7 bar network assets. So what that involved was us taking assets that were already being replaced as part of the REPEX programme, which I'm sure most of you are familiar with. And we then transported those to a holding facility at Leeds. And then when we were ready to test them, they were transported up to Buxton, and they were tested first on hydrogen. We then purged them with nitrogen and then tested them again on natural gas, and we compared the leakage rates. Interestingly enough, early results showed that the leakage rates are very similar, so that it doesn't leak any more on hydrogen than it does on natural gas, which is very positive for us. In terms of phase 1B, which is another piece of work that we were doing on phase 1, this was in collaboration with DNVGL, and it was based at their Spade Adam test site up in Cumbria. I'm not sure if any of you know of that or have been there. So what we're looking on that test site is the consequences of any leaks. So we had 3 purpose-built houses put on that site. These are all representative of UK housing stock, so they use different building methods and materials to represent the housing stock that we have in the UK today. One has a cellar, one has an attic, one has a garage. So we tried to look at all the different types of housing that the UK gas grid currently feeds and represent that within these 3 houses. I think one of them has a concrete floor, one of them has a block and bleed floor, to try and give all the different scenarios that we might see if we do get a leak on the network. So it looked at the consequences of a leak, and we observed the tracking dispersion of that leak and any ignition potential and explosive limits. So if you look at the picture there, it shows you the 3 houses. We've surrounded that with a ring main, and we deliberately put leak parts into that ring main and released hydrogen from those specific leak points, and then monitored how far that leak tracked and dispersed. In addition to that, we took what's called an ignition box, and we put in known sources of ignition, so sources of ignition that we know start an ignition on methane. We put those within the ignition box and we filled that with hydrogen and looked at how much hydrogen is required for it to ignite. We also looked at explosive limits, so we took a kiosk, just an everyday kiosk that you see on the network today, and we filled it with hydrogen to see how much hydrogen would be required before it actually exploded. One of the good findings that we had from that particular test experiment was that we couldn't fill the kiosk with hydrogen because the particles are so small. It just dissipated and wanted to find every crack and escape the kiosk as quickly as it could, and we actually had to wrap it in order to maintain this hydrogen supply to get to any sort of explosive limit. We looked at large releases as well, because one of the main things that we get on our network which does result in failure is when we have third-party incidents where they've accidentally knocked one of our gas pipes. So we looked at, if that happens, what are the consequences of a third-party strike, for instance. So all of these testing and results happened throughout 2018 and 2019. We're now looking at analysing those results, and we're very close to releasing the report for this. It's just going through the last phases of peer review. So it's actually next month that we're going to be releasing the report on H21 Phase 1. And we will have a webinar to launch that. If anyone's interested in that, please let me know and I can get you on the invite list. In addition to the testing at Spade, Adam and Buxton, we also did a quantitative risk assessment. So anyone who's familiar with the UK gas industry will know that we have a quantitative risk assessment, and this measures the probability of leaks, failures, subsequent ignition events, and it gives you an overall risk for using natural gas within the network. So the results from Phase 1A and 1B are being analysed, and they're now being input into an updated QRA, which is going to be a QRA that's purely for 100% hydrogen. So that will inform on if the risk is greater, less, or the same for a hydrogen network. So we're going to look at the overall safety of the network through this, and it will assess any key areas where any further mitigation may be required. They are working on that at the moment, and again, they're in the final stages of peer review, and it's one of the main things that will be referred to in the report. So that's going to be interesting to see what those results are. I must admit, I'm not party to a lot of these results. This is something that we've worked with DNVGL on. It's the people who worked on the original natural gas QRA who've been working on our hydrogen QRA. It's very specific work, but interesting. We also looked at social sciences. So it's all right as a network us saying, yes, it's very possible and safe to put hydrogen into the network, but that doesn't mean people are generally going to want that scenario. So we looked at talking to people about, firstly, energy, about what they know about the gas that they use today, and then kind of introducing this scenario of, do you realise that due to climate change you are going to have to change the energy that you use today, and that one possibility is that you could be using hydrogen. We did this in conjunction with Leeds Beckett University, who are social science researchers, and it was through a range of interviews and conversations that were very much unstructured, that took place on the telephone with participants. We also did a nationwide questionnaire, and then specific workshops which we targeted at specific parts of the UK. So we looked at Leeds, Birmingham and Manchester, and that's purely because they're the areas where the networks are looking at possibly rolling out hydrogen first, or are within industrial clusters that are looking at kickstarting hydrogen within their areas. So the high level results showed that safety is not a major concern for the public. That was a huge shock to us as the networks. We assumed that people would associate hydrogen with Hindenburgs and bombs, and they didn't. They assumed that if we're willing to put that in the hydrogen within their homes, that we would have made sure that it's safe. Cost and disruption are going to be barriers. There is going to be a cost increase for whatever climate change green solution we end up with, whether it's electrical or gas. There is going to be a cost implication, and that is a barrier. With hydrogen, it will mean that your bill may go up slightly initially, but it also means that you will have to change your appliances, and that disruption as well were a little bit of a barrier. We noted that people are able to digest quite technical information and retain it and explain it. So we explained the entire H21 project in quite a lot of detail, and as you'll know, working in the industry, it's quite easy to get bogged down with the technicalities of it and using acronyms and things like that. But the people who attended the workshops kind of understood that information, and then they were tasked with explaining that information to a friend or family member and recording that interview. And they retained a lot of the information, and they got a lot of the technical bits behind it that we thought they would struggle with. There is a lot of difficulty with some of the terms that we use, so we are all guilty of this. We use acronyms like they're coming out of our ears: CCS, SMR, ATR. And I can understand why there's difficulty with those terms, but there was also a difficulty with the term decarbonisation, which again was surprising. It's something that we, working within H21, I just assume everyone understands what decarbonisation means and what that means practically for people, but this is something that we did relatively have to explain quite a lot. People want to be told the facts, they want to know what's happening now, not what might happen, and they want to be brought along in the journey. They don't want to be just in a scenario where all of a sudden government have made a policy decision to change to hydrogen and this is what's happening. They want to be told before that this is what could happen, this is how it's looking at the moment, this is where we're at, and this is the possibilities. In terms of reactions to hydrogen, the UK-wide survey showed us that 20% of the UK population will naturally accept that change to hydrogen, but 12% will reject it. Those two groups were broadly very similar. They're very educated. The 20% have looked up about hydrogen and know a lot about it. The 12% tend to be more leaning towards the electricity solution, which is fine. But the 68% in the middle are very unsure. They're cautious, disinterested or concerned, and it's just everyday ordinary people who live very busy lives, working, looking after children, and just haven't considered their energy choice or how that affects the climate in general before, and they need a bit more information, and that's something that we're going to work towards. That's also detailed within the H21 NIC report that we're going to release next month, but it's also in a separate report which you can download from our website now if anyone's interested in that. Following on from phase 1, we started to think about what's next. So what comes next for H21? What do we need to kind of look at and investigate before we're in a position to be able to roll out hydrogen? And that led to our H21 NIC phase 2. So we submitted a bid to Ofgem last year to fund that particular project, and we were successful in November last year in receiving funding for this second phase. And this is looking at the next stage of evidence that we need, and it's primarily safety-based evidence, and it's going to underpin any future move towards a community trial. So I haven't included slides on that, but I can talk about that briefly at the end, but there are plans for a phase 3 already. So phase 2 is made up of 4 stages. So 2A is going to look at network operations. So we're looking at the network operations, the standards and procedures that we use today as business as usual, and seeing whether or not they can still be used on a hydrogen network, and if not, do we need to modify them in any way? So the work's been undertaken at DNV-GL's Spade Adam site again. It's extending the phase 1B test site, so that we're going to put in addition to the I've lost my words, I apologise. In addition to the ring main that we put around the houses, we're actually going to attach that to a mini network or a mini grid. Microgrid, I think, is the word that we've termed it, and it's going to represent the UK gas grid in terms of the pressures and the tiers that we have. So we've got the design for that, and the build has just started up at Spade Adam on that. Testing should be starting in January, and we're going to look at actually undertaking certain procedures that we do as business as usual. It might be maintenance procedures, it might be things like bagging off. I'm trying to think of other things that have been specific, connecting in and things like that. So yeah, that's all been worked on. In addition to that, HSE have looked at our procedures and standards, and they have looked at specific ones that they think we will definitely need to test on this microgrid, because there are so many different procedures. It's going to be impossible to test every single one, but they've done an appraisal of the ones that we already use, and they've highlighted the ones that we will definitely need to test. Some may not need. I know purging is one that they're definitely looking at, and that's probably going to be the first set of tests that we investigate down there. Phase 2B is an unoccupied network trial, so we can simulate everything that we want on that microgrid, but it's important to note that that grid is a brand new grid, and what we're aiming to do ultimately with H21 is actually transport hydrogen through the existing gas grid. So a lot of this is establishing confidence that an existing network can transport 100% hydrogen. So what we've done, we've identified a site at Redcar. We've been given permission to lease the land from Redcar and Cleveland Borough Council, and we're just going through planning permission to change the use of that land. That particular graphic there shows the land with our plans for the site. You're not going to be able to see much on the site, because what we're planning to do is actually convert those pipes from natural gas through to hydrogen. So it'll be the first part of the network anywhere in the UK that will actually be converted to 100% hydrogen. It's in a section of the network that isn't currently used, but it is still live. So we're going to disconnect that from the live part of the network, connect it up so that it runs as you can see, and as well as testing the conversion process, we're also going to look at testing some of the procedures on this network that we will have already previously tested on Spade Adam, because as I say, that's a brand new network and this is an existing, and we may come across things that do make a difference. For existence, we've not done any investigations yet into dust pickup or noise or anything like that, and these are things that we need to understand before we're willing to put hydrogen fully into the network. We're also going to do some more QRA work. So I don't know if any of you are aware, as well as H21, there's also a project or programme of projects called HYPHAHE. So this is funded by BASE. It's a £25 million funding programme, and it's managed by the HYPHAHE team, which I believe are members of Arab. And what they are aiming to do is provide stimulus to produce hydrogen appliances. So that's your cookers, your boilers, your fryers. But it's also looking at industrial and commercial appliances as well. They have produced a QRA which is solely concentrating on the use of hydrogen within the context of these appliances. So what we hope to do is create an end-to-end, or it won't create an end-to-end as such, because it's very difficult to kind of create one entire QRA, but what we're going to do is link the QRA that we've got from phase 1 with the HYPHAHE QRA and give an overall picture of the risk of using 100% hydrogen network both upstream and downstream of the meter. So that is something that we're working on. DMVGL, who are our QRA experts, are going to work on that along with the HYPHAHE team. So that's really interesting. It'll be the first time that the network will have ever had an end-to-end QRA. So that's really exciting. We're also going to continue with the social science work. So we're going to look at how we talk to people about hydrogen and a possible hydrogen conversion, what questions need answers, what language needs to be used. We're going to produce a golden set of rules about how to communicate about hydrogen and a hydrogen conversion, and also an animation and a possible interactive display which will explain the hydrogen journey from production right through to end use, because that's something that people have asked us quite a lot. Where does the hydrogen come from? How will it affect us? What will the appliances work any differently? So these are questions that we're all aiming to answer, but we need to know what language we need to use, how we communicate with those people. We might push a leaflet through the door, but increasingly these days people prefer to look at content on the internet. So it's exploring all those different ways of communicating and how we can do that when we're in a position to convert. In addition to the 2 NIC projects, we've also got a suite of NIA funded projects. So for anyone not familiar with the term, NIA stands for Network Innovation Allowance. So each gas distribution network gets a pot of funding, if you like, to use on innovation projects. And we're lucky enough that quite a number of our projects are funded through NIA. So we're currently looking at kicking off quite a few of these. So field trials was a pre-enabler to phase 2, and that looked at designing the microgrid that's currently being built and looking at getting the site at Redcar, which at that point in time we didn't have a site, but looking at where the suitable site could be. We're also looking at occupied trials, and again that's going to be a pre-enabler, looking at where we can possibly look at occupied trials and putting this into the network for people to start using. That will form our phase 3, and that's something that we're actually working quite closely with BASE on and the other networks, so it's highly possible that you will see trials within the next 2 to 3 years, and it won't just be NGN that will be doing trials, it may be SGN and Cadent and Wales and West as well, so it's something to look out for. We also realised that a massive gap in our knowledge was that we completely considered domestic customers but not industrial and commercial customers. So that's a project that we've just kicked off recently to look at who our industrial and commercial customers are on the network and what their needs are going to be in terms of converting to hydrogen. Some of our customers that are industrial simply can't have a break in their gas supply. So how are we going to deal with that? It also may be that certain customers like to be converted when they are on a natural shutdown. So this is something that we're going to be looking at over the coming months. We're also looking at an initial hydrogen supply strategy. In order to start supplying hydrogen, we're going to need a lot of hydrogen. Is that going to come from a national hydrogen transmission system? Is it going to be more localised? And that's a project that we're kicking off with DNVGL to look at what are the options that we've got and what are the possible ways that we could start that supply strategy as we look to convert areas. We're also going to look at the compatibility of services with hydrogen. And this is something that we'd not previously considered, but something that BASE highlighted to us needed looking at. And that's going to involve testing up at DNVGL's Spade Adams site again, and also the compatibility of components. So there's lots of components that we use on the network, linked to our pipes, valves, etc., that we just don't know how they're going to react to hydrogen. Are they going to degrade quicker than they do at the moment? Is the glycol and glycerine not going to work with hydrogen? Is it going to make it dissipate quicker? Are we going to have more leaks? So these are all things that we need to consider. So as I said, we've got future proposals for H21 Phase 3 occupied trials that are in the pipeline, if you like. I know that's a bit of a cliche, I apologise for using that. But we've got quite a lot of evidence so far, so we can say more or less confidently that it's going to be safe. There will be some mitigations needed, but there is a hell of a lot more work still to be done before we're in a position as an industry to convert properly, but we are working towards it. And there's not just H21, there's H100, HYPHAHE. Some of you may be familiar with HyDeploy. That's actually a project that's blending 20% hydrogen into a closed network at Keele University, and shortly we're going to be blending 20% into a part of our domestic network at Northern Gas. So yeah, lots happening. Thank you, and any questions?
Thank you very much, Stella. A couple of questions on the chat window. If anybody does have any questions, just type them away and we'll get Stella to answer them. First one from David. As part of the leakage testing, was the interaction of the hydrogen with anaerobic seals evaluated?
There was, yes. I know that they looked at anaerobic seals and they also did some repairs on leaks that we did observe to see if that repair would hold up. I don't have the results because they're still being peer reviewed, but I understand they were quite positive.
No problem. Any more questions? People just type away if you can think of anything. One from Phil Clisham. What is the possible timescale for large-scale conversion of domestic network in the UK?
So we're looking at rolling out phase 3 trials early 2020, so maybe 2022. And following that, I think the government's plan is that we would go from trials to more larger demonstrations, so bigger areas. So trials are going to look at maybe 600, 700 properties maximum, whereas demonstrations are going to be a lot bigger areas. And after that, it will then be a policy decision from government. So I would probably expect 2030s before we start converting. There's still quite a lot of work needs to be done, and we are on with it. It's just a hell of a task.
Big job.
Yeah.
One from Jonathan Corrigan. Will the test sites be kept in commission for possible third-party testing?
Yep, so the test site at Buxton, we've actually handed that over to HSE, so they now own that site. They've decommissioned and mothballed it, but it is available for anyone who wants to do any further leakage testing. They just need to contact the HSE. And my understanding is that the Spade Adams site, we've got another year of testing on that on the new part. But my understanding is that eventually they'd like to create that into a training site, so that gas operatives can be trained on a hydrogen network up there. So that's my understanding of what their plans are. But yeah, I would imagine. I know that the houses were actually used for HYPHAHE testing. So they put appliances in there and tested the leakage. So yeah, it's highly possible. I would contact DMV or HSE if that's something that you're looking at doing.
Any more questions? One just coming from Peter. Peter O'Sullivan, are we considering using both blue and green hydrogen as potential sources of supply?
We are. The ultimate goal is green hydrogen. I think it always will be. It can't produce the demand to scale that we need in terms of supply. So we will be looking at utilising blue hydrogen initially. And it does get a lot of negative press as blue hydrogen, understandably, because it does look like the gas industry are just trying to find another way to carry on using gas. But we will need it just for the pure amount of gas that we use as a UK network initially.
Question from Neil Glover. This is going to be difficult to answer. When will approved dual fuel hydrogen compatible appliances be available to users? And when is it likely that all appliances sold will be required to be hydrogen compatible?
So there's no plan at the moment for when appliances will be hydrogen compatible. I know that 2 boiler manufacturers in particular, Worcester Bosch and Baxi, already have boilers that can run on hydrogen. They are exactly what you said, they're dual fuel. They initially run on natural gas, and then I believe, I've not been to the warehouse, some of my colleagues have, that you switch one of the burners and then you can use them on hydrogen. So they're already producing those now, and they're being used in a lot of our trials and testing. Baxi are pushing for the government to have some sort of policy in place within the next year or two that makes it mandatory for hydrogen ready boilers to be the standard that is bought by consumers. So yeah, I think we're close. It just needs a little bit of lobbying of the government.
Probably the final question from Will Atteridge. Have the suppliers and manufacturers of pipeline components been contacted for inclusion in your analysis? Materials and seals will be critical to the H2 solution.
That particular project on components we haven't kicked off yet, but that is the plan. I know that we do have some plans to include some suppliers of components and pipes in the work that's happening at Spade Adam. I believe there's an event happening November sometime where we're going to invite suppliers and introduce them to what we're doing on that particular part of the project and see if any of them are interested in being involved. So it's definitely planned. It is something that we had considered. So yeah.
Neil's just sneaks in another one. Can you see grey hydrogen be used to get the system started and then phased out as blue and green hydrogen become more readily available?
I think it would be very difficult from an environmental perspective to have grey hydrogen accepted. It is something that is mentioned in reports. It's never something that is mentioned in reports in terms of we will be using it. It's more in the context of it already exists and we're already producing it. I think the government would have massive pushback, but anything's possible, to be honest. They are definitely looking at CCS in terms of blue hydrogen.
Getting a lot of feedback there. Sorry, but thank you very much for your time today, Stella. It's a really important report. Turnout's been tremendous. I think we've had over 40 at some point in the talk. It will be available on the on YouTube. If you look under Pipeline Industries Guild, we've got our own page with quite a backlog of talks. But this one should be posted in the next day or two, and you'll be able to watch it again or pass it on to colleagues if you want to see it. 2 talks coming up next week on 3D LiDAR modelling and R2M on Tuesdays and Thursdays. Just check the Pipeline Industries website. Thank you very much again, Stella, for today.
Thank you, everyone.
Cheers. Goodbye.
Bye.
Stella?
Yep.
Are you able to hang about? I just got a couple of quick questions just on that.
No, that's fine.
That'd be great, thanks.
Rebecca, do you want to stop recording?